All right, this video is going to deal with the cost and advantages of home ownership. This is section 13.4. We're primarily going to be looking at, in this video, we're going to primarily be looking at characteristics of fixed rate mortgages. I'm going to post the notes for the adjustable rate mortgages, but you won't be responsible for any questions related to adjustable rate mortgages in homework quizzes or tests. Okay. And then I will do a video on, the closing costs associated with mortgages and also recurring costs of home ownership. Okay. All right. So let's go ahead and get started on this one. So a loan for a substantial, let me get my cursor. There we go. A loan for a substantial amount extending over a lengthy time interval, like 30 years, for the purpose of buying a home or other real estate where the property is pledged as the security for the loan, meaning if you can't wind up paying the loan, the property is like the collateral. That is called a mortgage. Okay, and it could be a deed of trust or a security deed. The time until the final payoff is the term of the mortgage. So that would be like the 30 years or the 25 years or however long you're going to take to pay off the loan. Okay. The down payment is the portion of the purchase price of the home that the buyer pays initially. So you're going to pay that up front and then finance the rest. And then the principal amount of the mortgage is the amount borrowed, and it's found by taking the down payment away from the purchase price. That part is pretty much just like what happens with installment loans. Okay. Now there's two types of mortgages, and there's probably more than two types, but there's two main types: fixed rate versus adjustable rate mortgages. With a fixed rate mortgage, the interest rate remains constant throughout the term of the loan. So like for all 30 years or 25 years, the interest rate will be the same. And the initial principal, together with any interest due on the loan, is repaid to the lender through these regular, usually monthly payments that you make. And this process is called amortizing the loan. The regular payment needed to amortize the loan depends on the amount financed, the term of the loan, and the interest rate. Okay. So the formula for this, for figuring out the regular monthly payment that's required to repay a loan of P dollars, okay, with an interest rate R that's annual and a term of T years, can be calculated using this formula right here. So it's a little intimidating and it can be difficult to type it into the calculator correctly. So be sure you have your calculator and be trying these problems as I do them with you. You will not have to memorize the formula. Plus, there'll be many instances where you'll be able to use something much simpler, a table, to calculate your payment rather than having to use this formula. Okay. All right. So this formula will give you the regular monthly payment you will need to make to repay some loan. Okay. And you're given the interest rate and the term of the loan. Okay, so we're going to try a problem here. And I really want you to have your calculator. So go pause this, go get your calculator, because these can be really hard to type in correctly. Okay. All right, so let me go ahead. Try and get a bracelet off my arm. Oh, well. Okay, so let's go ahead and plug everything into this. So let's suppose that we took out an $80,000 mortgage. That would go where P is. Interest rate was 6%. So just like on other formulas, that's 0.06. We're going to divide that by 12. You don't really have to know where the formula came from, but they're doing that, dividing it by 12 to get the monthly interest rate. All right. And then all of that we see gets divided by 1 minus left parenthesis 12 divided by 12 plus the 0.06. Close that, and the exponent will be 12 times the term of the loan, which in this case is 25 years. Okay. So definitely do at least this before you go to type it into your calculator. Okay. On the bottom, you would want to definitely at least say 12 plus 0.06 would be 12.06. And then make sure you do the 12 times the 25, which is, let me erase this right here, which is the 300. Okay. And make sure you got your parenthesis where you need it. I had it in front of the 1. I am going to put 1 there, but what's important is that exponent of 300 only goes on this 12 divided by 12.06. Then once you get that raised to the 300 power, it is subtracted from 1. Okay. So let me get this written. And, sometimes when you do, I'm going to use my calculator to kind of time how long it takes me and stuff. Sometimes when you do like the 0.06 divided by 12, it'll turn out being nice. Like this one turns out pretty nice. So you could do it in pieces, but you don't want to introduce rounding just all over the place. So it can be better to go ahead and calculate, the whole thing at once, but it can be a challenge to understand how to type this in. If I were to type this in all at once, this horizontal fraction bar is important to understand. It is a grouping symbol that means this has to all be done, then divide by all of this. Okay. All right. So if I were to type this in, I need to move over a little bit because it's going to be long. I could type in the 80,000, okay, times the 0.06 divided by 12. And all of that would get done because it's multiplying and dividing. So that would happen even if I didn't put parentheses around it. All right, then I need to divide by, and here's where we can get into trouble if we're not careful. All right, this right here is a minus sign, and subtraction, if you think about PEMDAS, happens near the end of a process. So what I really need is this left parenthesis when I put in this 1 minus the 12 divided by 12.06. And then you also need to be careful about the fact that that needs to be done right there before you raise to the 300 power. Otherwise, you're not really doing what it says. Okay. So just emphasizing, if you're going to do this in one step, you can, but you have to be careful about how you type it and understand the importance of order of operations. So I'm going to go ahead and recommend you do numerator in parentheses, and then you're going to divide by, oops, I don't want that in red. Okay, let me just erase that. Okay, I want that red out of there. There we go. Then you're going to divide by the denominator in parentheses. So that's this right here. Okay. And I meant for this red one. So let me get you to kind of hang on a second because I got my parentheses not where I really wanted them. So you're going to do the numerator in parentheses. So I really meant, I did it again. I don't mean that. Hold on, guys. Okay, let me try one more time. The numerator in parentheses and then the denominator in parentheses. Okay, that's better. That's what I wanted it to look like. Okay, so you need to learn how to make sure that you're very careful when you type it in, and you should be trying this with me right now. So take a moment, pause the video and do it. And then let's check and make sure that you got the same thing, that we all got the right thing. Okay. And when you're done, you should get about, I'm going to do it in red so it shows up, about, this should be the monthly payment you would have to pay off this loan. Should be, that's supposed to be a dollar sign, $515.44 about, if I round to the nearest hundredth. Okay. And that's what we wanted. So the formula will calculate what your monthly payment would be on that mortgage. So for every month for 25 years, you would have to pay $515.44. Okay. And that means that you would have paid off that loan amount plus any of the interest you would owe on that. All right, now here's the thing. That formula, sometimes you have to use it because you won't be able to find the mortgage, you won't be able to find the aspects of the mortgage in this table. But I want you to look at this table here. It's another way you can calculate your monthly payment. Okay, and there's also calculators that'll do it. The time value money solver on a calculator. Okay, you'll be expected to do it using the formula or using this table and being able to show your work. All right, so what the table gives you is the how much you would pay for every $1,000 of principal. Like, so if you borrowed $10,000, you would take any of the factors in the table that you see and multiply by 10, because what you see in the table is how much you would have to pay for $1,000. So if your loan were for $10,000, you'd have to multiply those by 10. And they usually include typical interest rates and typical terms. So like every 0.5%, 5, 5.5, 6, and so on. And then the terms being things like 15, 20, or 30 years. Okay. So if you wound up having a mortgage that was going to be 18 years, you couldn't use this table. Or if you had an interest rate that was like 6.2%, you'd have to use the formula that we just used. Okay. So let's use the table now, and we're going to use the same information. So it's still an $80,000 mortgage, 6% annual interest for 25 years. So you're going to look at 25 years and it was 6%, and you're going to find this factor in the table. Okay. And that's basically like $6.44 is what you would have to pay if you borrowed $1,000. Okay. But you're borrowing 80,000, right? So you're going to have to multiply that by 80. And then when you do, that turns out to be 515.44, okay, which is, as you notice, what we got back on the previous problem that we did when we did it using a formula, okay? So figuring out a mortgage payment, we do it differently than we do with installment loans. We use a special formula or a special table, and this table can't be used for those installment loans, and that formula can't be used for those. That's where you just use the regular old simple interest and so on. Okay. All right, so we're going to do a little more with fixed rate mortgages. Okay. I want to do just two more kind of straightforward questions. And then in another video, I'll talk to you about trying to understand this amortization schedule, and we'll create a portion of that. So let's do this problem here, and then I'll stop the video and do another one on amortization schedules. All right, so this question is asking us to get the monthly payment needed to amortize the principal and interest for each fixed rate mortgage. Okay, so we're going to look at these examples. Okay. All right, so what you need to do is look at the interest rate and see how it's 5.2%. Go to the table, and what you notice is it's not in the table. Okay. So you're going to need to use that formula that looks so bad. Okay. The term was in the table, but the interest rate was not. So you're going to go to the formula. Okay. So the formula had you take P and then your interest rate, okay, times your interest rate divided by 12, okay, and then the 1 minus your 12 over 12 plus your R, and then that 12 over 12 plus R was raised to the 12t power, okay? All right, so I got that. You'll have it on a formula sheet, and you just have to find that formula right there when your interest rate is not in the table, and write it down, and then plug in, and then make sure you're using your calculator properly. Okay, so let's go ahead and get everything plugged in. So the principal would be $145,000. All right, the interest rate, we're going to multiply by the interest rate. And look, when you change that to a decimal, be careful. It's 0.052. You'll divide by 12 always. That's part of the formula. Okay. Right. And then in the denominator, I'm going to do 1 minus 12 over 12 plus 0.052. And then that is going to be raised to the 12 times 25 because t is 25. Okay. All right, so we're going to enter the numerator, 145,000. Oops, too many zeros. Don't do that on the calculator. And then times 0.052 divided by 12. Okay, that'll all work like you need it to. Then divide by parenthesis the denominator, 1 minus another parenthesis, 12 divided by 12.052, close the parenthesis, and make sure here that you raise it to what 12 times 25, like do that on your calculator so you don't have to put another set of parentheses. And 12 times 25 would be 300, right? Yeah, 250 and 50, 300. So you're going to raise to the 300 power, and then that would close, and that's your denominator. Okay, those can be difficult to enter, so make sure you had your calculator right now and try it. Pause the video if you need to. You want to make sure you can enter those accurately. All right, and that turns out to be $864.64 about. So your mortgage payment would be $864.64. All right, now compare that to B. In B, first thing I'm going to do is check the interest rate and the term and see if I can use the table. So 5.5%, I remember that every half of a percent was in the table. And then I'm going to look at the 20 years, and 20 years is going to be in there because it's a pretty typical thing. So I'm going to go back to this table, and I'm going to look for 20 years and 5.5%. Okay, was it 5.5? Let me go check. I think that was what it was. Yeah, 5.5%. Okay, so I'm going to take that 6.87887. 6.87887. That's the factor that would be how much I would pay for $1,000, but my loan amount is $200,000. So I need to multiply by 200. Okay. And when I do that, I get about $1,375.77. $1,375.77. So this one had an interest rate and a term that was in the table. So I'm not going to go through the formula because I don't have to. And there's my answer.